Hello, everybody. Mr. Rubo here. Today we are talking topic 3.3, which is evaluating sine and cosine function values. Okay, so there's a few different methods of doing this. One is just memorization. Now, there's nothing wrong with memorization; it works, but we prefer a different way, which is using reference triangles and angles. Okay, if you go the memorization route, you might actually using this method, like the reference triangles and angles, like throughout this course, we do enough of the same things that you might just memorize it without needing to draw these triangles. But starting out, we recommend draw the reference triangle because then you really only need to memorize two things as opposed to like 12 things. So we're going to sketch a reference triangle, and it's always going to be the triangle. The angle is always going to be the one that is made with the x-axis because it's got to be in standard position. Okay, and then specific angle values will yield ratios that can be determined without a calculator. So there are two types of triangles we're going to deal with: pi 6, pi thirds, pi halves triangles, and pi fourths, pi fourths, pi halves triangles. If we're talking them in degrees, which again, we're not going to deal too much with degrees, so we want to get more used to doing it this way. But for the sake of this video kind of starting out, pi 6, pi thirds, pi halves, that's 30, 60, 90. Pi fourths, pi halves, that's 45, 45, 90. So if you remember those two types of triangles, you can find almost all sine, cosine, and tangent values in this class. Okay, so again, we're going to do our reference triangle. So I'm going to draw pi 6 as my angle. With the x-axis, pi thirds is up here, and then 90 degrees would be down here, or pi halves. Okay, and if you recall from algebra 2, we did this ratio w pi w root 3 and then 2w. Okay, and we're going to use that same ratio when it is pi thirds is the angle, right, is the reference angle. So, oh no, there we go. My pen just likes to not work sometimes. So yeah, there's that, and then this would be pi 6. So again, remember, across from the pi 6 is the w, across from the pi thirds is w root 3, and across from the pi halves, where the right angle is 2w. Okay, and then the pi fourths, pi halves triangle, that is that isosceles triangle. So this is pi fourths, and there's our right angle. These two sides are the same, so we call them both w, and then the missing third side, that hypotenuse, will be w root 2. Okay, so you know these two triangles because these first two are kind of the same. So if you know pi 6, pi thirds, pi halves, and pi fourths, pi halves, those ratios of sides, you can solve most trig questions in this class. So, and you may be like, well, those were only in the first quadrant. Well, these triangles can be reflected to yield similar values in other quadrants where some of the values will be negative. So in other words, I'll take, we'll just do the first one. So I'm going to draw it in quadrant 1. So there's pi 6 is the angle. I'm going to have the right angle there. And then this is w, 2w, w root 3. Well, I can reflect it over the y-axis. It would come here. This height is still w. The hypotenuse is still 2w. This reference angle is pi 6. That's why it's the same type of triangle. And then it's still w root 3, but it's to the left, which means it's negative. And then I can flip the triangles upside down, right, over the x-axis. And if my pen wants to work, there we go. Ooh, that was ugly. Let me do a different color. I can flip it this way, and guess what? This is still negative w or root 3. The hypotenuse is still 2w, and then this one would be negative w because it's going down, and the angle is pi 6. And then our last one, it's this bottom right one. So this is still pi 6 is the angle. Now it's negative w. this is still w root 3, and then the hypotenuse is still 2w. So you can see here, like, we can use those triangles in any quadrant as long as we know what the reference angle is. And so if we're asking you to do it without a calculator, it's going to be most likely pi thirds, pi sixths, or pi fourths reference angles. Okay. So if a given angle has a terminal side that lies on an axis, use this unit circle where r is 1. So this is kind of the special cases when you can't form triangles. That's what this one is talking about. And then the last thing here is just to recall, cosine is adjacent over hypotenuse. Sine is the opposite side over hypotenuse, and then tangent is opposite over adjacent. So we have our triangle, our angle, we call it a reference angle because that's where we're referring to figure out what opposite and adjacent are. So opposite legitimately means opposite the angle we are referencing. The adjacent side means next to. There are always two sides next to each other, or next to the angle, but one of them is always the hypotenuse. So, and the hypotenuse is the one across from the 90, or across from the right angle. Okay, a couple notes here. Any reduced angle with a denominator of 6 will have a reference angle of pi 6. Hold on. Pi 6, there we go. Any reduced angle with a denominator of 4 will have a reference angle of pi fourths. And then any reduced angle with a denominator of 3 will have a reference angle of pi thirds. This is where radians really shines. It saves us a ton of time, because if I told you something like, I don't know, 37 pi over 6, well, I already know, because this fraction's reduced, I know the reference angle is going to be pi 6. I still have to figure out which quadrant it's in, but I know what my triangle will look like. I just got to figure out which quadrant it's in. If I had 111 pi fourths, I don't know what that would be in degrees, but I do know my reference angle is pi fourths. Same thing with pi thirds, right? That's the beauty of radians, is as long as that fraction is simplified, you know your reference angle without doing any work. Okay. So yeah, that's it for today's video. Thanks for watching. Have a good day.